Alright, should almost be live soon, maybe. Yeah, about now. So this is a draft physics.com and debatephysics.com also. Video presentation and such. And I will be with you in a moment. Just have to get to the live video and such. Open the chat in my other account because YouTube won't let me use my regular account for anything because it's basically, an evil empire that censors content whenever possible and such and so forth and whatnot. Okay, so still on the kinetic energy subject this time anyway, and the Joule tank. So I should be able to illustrate or describe. Okay, so basically it's just this tank doesn't look insulated, but it's an insulated tank of water. The idea, you have paddles inside of it, and how Joule did the experiment wasn't, he didn't tie it to a horse or tie it to a car or tie it to, there was no cars back then, but some other way of creating an energy source and converting it into heat. And so the basic principle is that any motion could be converted into its heat component, and then you could always compare two things. So his interest was really in figuring out whether steam engines were more efficient than electric engines. So because electricity was the new thing, and so he was going to be purchasing hardware for his brewery, and he wanted to know which was the better investment, and technically. And so, but there's nothing in his experiment that has anything to do with either the steam engine or measuring electrical motors. So that's the weird part. So anyway, so what he has is that he puts weights and lets the weights fall and turn the paddles. And I've always seen it illustrated with just the weight on one side, but it sort of makes sense to have them on both sides just to even the tension, and so it all does make some sense. And so the idea was you would just raise the weights and then let the weights fall and measure the temperature change in the water. And so he made actually very highly precise thermometers. So that's another thing he was kind of famous for, is he made thermometers that were really, really, really accurate. So other things come out of experiments. So that's the great thing about experiments. So anyway, so these weights fall the same distance. So even though they're at different heights because of the way they're spun on the spool, they fall at exactly the same height, and they can just adjust how far they're going to let them fall. Now, what you can figure out sort of just obviously is that if I took the paddles off, or just put a tiny little paddle on this bar, you can understand that the weights would fall really fast, okay? And no heat would go into the water. And the bigger I make the paddles, the more water it'll move, and the slower the weights will fall. So, this is sort of the takeaway. My argument is kind of obvious, that yes, if the weights fall very fast, then all the energy will be in the weight hitting the ground. And the slower the weight's going when it hits the ground, the more of the energy you obviously collected, because you slowed it down. It doesn't hit the ground with a bunch of energy, so there's not a bunch of heat going into the ground, so obviously your heat went into the tank. So these are all kind of obvious statements you can make, that obviously the amount of energy you can get out of the system is variable depending on, frankly, how slowly the weight falls, because it's a time dependent force. You're collecting 9.8 meters per second of what would be velocity if you were free falling, but it's essentially a pressure, a weight. It's a momentum. And so every second a momentum, a pressure is applied. And this is the point, that the longer it's in the gravity, the longer it's falling in the gravity, the more gravity it's collecting. All right, even though it's falling slowly, we know that the energy is going into spinning either into, like, we could just tie this to a weight and drag the weight, a cart with wheels, And the heavier the cart is, obviously the slower the weight falls. The lighter the car, the faster the weight falls, but the less that goes into the cart. So, because it's light. So it has to always drag the car. So the car is going to have, in its linear motion, a representation of the amount of time, the weight spent in the gravity. So the heavier the car, the longer the weight falls, the more energy they'll get, more momentum they'll get in the car. All right, so the real takeaway, the trick of this experiment was doing it by height. So they emphasize height here. And you could sort of understand that this weight is not going to fall at its free fall acceleration. It's not going to go 9.8 meters per second, then 19.6 meters per second, then 20 whatever 8 per meters per second. None of that's going to happen. What it's going to do is gain a certain acceleration, and that'll be its speed. That's the speed it's going to turn, essentially, and it'll fall the rest of the distance pretty much at that static speed. So if I make 4 times the distance for the weight to fall, you can understand it's not going to be 2 seconds. It's not going to be 2 units of time anymore, because it's not accelerating. It's falling at a much more steady rate. Okay, the water doesn't get easier and easier to turn. The water stays about the same to turn once it gets up to its, once all the turbulence and everything else you're going to create is created, that's your speed, and you're not going to go any faster. So the fact is, 4 times the distance, the weight will probably take 4 units of time to fall that distance, 3 something. So clearly you're going to get 4 units of energy because you're going to really slow down how fast the weight falls. And that's the key. It's not falling at free fall. So the same rules don't apply. So the distance is essentially, if it's a constant speed, you can understand, oh, okay, well, at a constant speed, I'm going to collect the same amount of energy every second, and that's it. And so every unit of distance will be the same also. So that's the catch. So it's pretty easy to dissect and understand how they could pervert it into a proof, because they're saying 4 times the distance does equal 4 times the energy, but only equals 4 times the energy because this weight does not fall faster and faster and faster. It falls once it reaches a steady velocity. It stays pretty much at that velocity. So it's a real cheat, and it's just sad that these people, physicists, are not dumb, and the fact that they've never really analyzed any of these elemental experiments is tragic. So I could bring up the Chartres denting clay experiment. There's so many, so I'll bring that up. What the hell? I'm here, making the video, and you're just saying it's the same kind of thing that shouldn't have happened. So this experiment was after Chartres, and it was before, frankly, it was before they had really confidently accepted 1/2 mv squared, and certainly in that form with the 1/2 mv squared. But they were already on that road, and this was a this whole conversation was built into an understanding of thermodynamics and Lord Kelvin and the whole establishment of the Kelvin scale. So they did lots of good physics, but they did some really bad physics in the sense that it's kind of obvious, like I said, if they just watched these weights, they weren't going to accelerate at the Galilean rate. It wasn't going to be 1, 3, 5, 7, 9. That wasn't going to happen because the water doesn't allow that to happen. It won't allow increases in velocity as liberally, as free fall. Put simply, as simply as I can put it. All right, so we'll get rid of that and draw. That's what we'll do. I guess this pen should work. Oh, we'll find out. Ooh, it looks very black. All right, so this also you're just saying, okay, PBS. Lots of places have you know, done documentary style productions, making arguments about, you know, this moment in history, you know, where somehow something was proven. So this is 4 times the height, even though it doesn't look like 4 times the height. So it's twice the velocity. So you have 2v and you have 1v. Same object. Okay, just one of them with 1 velocity, one of them 2 velocities. I guess I should fix that. Defect in the camera. Don't know why it does that focus thing now and then, but anyway, close enough. And so what they did, you know, instead of, you know, penetrating clay, all they did was barely dent the surface of the clay. All right, and you can sort of understand, okay, that this object changes as it goes deeper and deeper into the substance. You can see the shape essentially changes. So when it's first hitting, just the flat bottom hits, and when it's further along, further deeper, the sides start to do the pushing. You can understand that pushing clay sideways is just one motion, but having to push clay down means, just like with water waves, that the direction of the energy has to be changed. So water, when you make a splash in water, the force wants to go this way, you know, out as rings, but it can't because it creates too much pressure. And so the only where the pressure can be released is going up. So it's essentially 2 motions. So it's more, it will require okay, more energy, and they're more likely to lose energy to heat and friction. So the fact is, the way this experiment should have been done was to allow the objects to completely penetrate the clay to their halfway mark at least, and then you could make the argument that they were experiencing the same amount of proportionally. One of them didn't have this advantage of pushing more in the downward direction and versus pushing sideways. So, you know, critical experiment, I mean, it's not hard to figure out the defect in the experiment. And the truth is, some amateurs have played with it a little bit, and, you know, they found that, yes, if they allow the object to penetrate, then it goes back to being the 2-to-1 relationship, not a 4-to-1 relationship. So the only reason why it's 4-to-1 here is because, yeah, this one has a huge advantage because this one was pushing clay down and this one was pushing clay mostly sideways, and that's the difference. That's one of the differences that's easy to see and easy to recognize as a flaw in the theory of the experiment. Now, second flaw is the faster something's going, the less actual friction it has, contact with surfaces, and it's going to waste less energy. So the slower, the more contact, the more it's directly converted into heat rather than motion. So this one creates more scatter, you could argue, in the clay, where the faster something's going, like a bullet going through a piece of cheese or something, it makes a very straight path until it starts slowing down, and then it starts making a mess of the cheese. So at the highest velocity, it's not connecting to the surface much, it's not disturbing the surface as much, and the slower the velocity, the more sticky it is, and so the more the energy is dispersing. So this has a high dispersal rate versus this also. So these are all physics arguments, all right, that could have been applied to these experiments, and they just weren't. Nobody did any analysis of the credibility of the experiment, and, oh, that's interesting. I think I unclicked that. Where'd the damn little arrow go? That's interesting. I mean, it might not be terribly interesting to you, but it's sort of interesting to me that it's gone. Where the hell did it go? What's back there? Nothing. You see where I left it? Oh, it's way down here. Yeah. Oh, well, there it is. Okay. Not important. Yeah. All right. So this goes here-ish. So I could, I have done it so many times, but I mean, I could also just point out again. I mean, it's just conclusive evidence because it basically does demonstrate that yes, if you acknowledge the truth of the circumstance, okay, if you acknowledge that you can get away with sliding across thin ice by going quickly across it, it just demonstrates that there's no logical room for this belief in kinetic energy. I mean, the last video I did these arguments, but I'll just do this one just again because it could be analyzed by somebody. I mean, a physicist should be able to look at this and say, oh yeah, I get it. All right, so this is 1 velocity, this is 2 velocity. Boy, it barely fits, but close enough. And the simple argument is that twice the velocity will travel 4 times the distance. And, people on its face, they say, okay, that means something. But it really doesn't, because it's deceiving you. Because the 1 velocity, you know what 1 velocity looks like. It looks exactly like this. And 1 velocity has to be here then. That's where 1 velocity, 1v has to be here. And that's half, okay, the speed. So it's going half its velocity 3/4 of the way down the track. So we know this is exactly the same as this. This takes 1 unit of time. This takes 1 unit of time. All right, and the fact is, if you measure the experiment, this takes 1 unit of time. So it's only 2 units of time. All right, it's not 4. The simple truth is, gravity is pushing down, creating the friction. Gravity is pushing it into the surface. And you know that in that 1 unit of time, I guess I should say 1, it's 9.8 over this entire surface. So it's 9.8 over this entire surface, and then 9.8 over this small surface. So you know that per inch, there's a greater amount of pressure on this than there is this, obviously. 1/3 the pressure, in fact. So you know it's getting pushed into the friction with less energy, less force. So clearly it's going to lose less energy per inch. Okay, so per inch the object's going to weigh less. The ball is actually going to weigh less per inch. It's applying less pressure. So obviously it's losing less to the ground because it's making less contact. So just like an electrical conductor, this is a weak connection and this is a strong connection. So lots of voltage can go out here. Very little voltage can leak out here, is a simpler way to say it. But it's clear that this is only going to be 2 units of heat. Okay, and that's all it's going to be. It's not 4 units of heat. And you're taking all of the linear motion out of the experiment. So the whole point of this friction experiment is to steal all of the energy, put it all into the ground, and the simple understandable argument is this puts twice the energy into the ground that this does, not 4 times the energy, because the friction is much lower here than it was here. Fact. So easily analyzed. I mean, I didn't say anything nobody can argue that I said anything incorrect here. This is how the actual thing works. That focus is off. Oh, there, now it's better. I don't know why it does that kind of crap. All right, so a little too late to fix it, but whatever. So it means decisive evidence. And so I have to keep making these videos. I mean, I'll die and, these videos will still be up and, we won't be able to get anybody to provide a rational explanation. So I asked AI, the obvious question, and it will produce nothing, in terms of a rational response. But I mean, I asked it the question, does 3 times the velocity create 9 times the ability to do work? And it says, yes, of course it does. There's no evidence of it. Okay, so, and, and so the simplest experiment I have been able to devise is just some simple thing with springs. Okay, and so I have the springs are all the same. I'm going to compress them with the same amount of force, and you just have 3 objects. And the idea is that you launch one, you get 1 unit of velocity. You launch 2 of them, you get 2 units of velocity. You launch all 3, you get 3 units of velocity. Now, the obvious point is I did not do 9 times the work. I only did 3 times the work to create 3 times the velocity. And it's just an absolute fact. The momentums are going to be perfectly consistent with Newton's third law. I have the same 1 unit of mv, 1 unit of mv, 2 units of mv, 2 units of mv, 3 units of mv, 3 units of mv. No way of getting around that. And there's no hope for some theory that it took 9 times the force or energy or pressure or anything to create 3 times the velocity. I made 3 times the velocity by only doing 3 times the work. Absolute fact. And of course there's no evidence that this object now has, going 3 times the velocity versus 1 unit of velocity, that it has 9 times the energy, or that it'll do any crushing or smashing. That'll be 9 times. And that was proven by the Mythbusters when they crashed a 50-mile-an-hour car into a brick wall and then a 100-mile-an-hour car, and all they got was twice the crushing, not 4 times the crushing. Now, it's too bad they didn't run the car at 30 miles an hour and 90 miles an hour, because then they'd have to prove that it did this 9 thing. The more they do that differential, the more it becomes obvious. So, do you really think the car, going 3 times as fast, 90 miles an hour versus 30, do you really think it's going to be 9 times the crushing? And no, it's going to be 3 times, because it's only 3 times the velocity. And all there is momentum in the universe. So what I really wanted to do with this video was argue in defense of the Descartes. Because he was the first one others had said it, that energy is conserved, that the energy in the universe just moves from place to place. But it's just an absolute fact. And it doesn't make any sense if I can change how much energy is in the universe by merely taking energy from a big thing and putting it into little things going fast. It can't be more energy. I can't make 9 times the heat, out of 3 times the momentum. It can't do that. All right. So, so what's your new equation? There's no MV. You can't. I don't want to have to. What equation do you need? MV equals energy. That's the only equation. MV equals pressure. MV equals weight. MV equals heat. Heat is mass moving. Everything that moves is an M and a V. And all you can do is either reflect it or absorb it. Amazing. I agree with the sliding ice argument. It's logical. Well, you'll agree with a lot of these arguments, so your opinion is nice to hear, but obviously we have to convince others that it's irrefutable evidence of the fact that friction is variable and inversely proportional to speed. The faster something's going, the less friction, if you're using gravity to create the friction. If I was using wind and I was dropping something, the same truth would exist. It's how strong is the wind, but the fact will be is if I'm going twice the speed through the wind, I'm going to have the wind's going to be less effective at pushing me into the surface. So the same argument is crossing a stream. I mean, we've done all these, so many times, and it's just so obvious that if the stream's flowing and I'm going to try to cross it, okay, in a little boat or whatever, the faster I go, the less I'm deflected, the less energy I get in this direction. I collect less. And the slower I go, the more I collect in this direction. I mean, it's just so obvious. It's about how long you're in the force, not how much distance you cover while being in the force. All right. So which one was I going to do next? Oh, yeah, I was just going to do something to illustrate the Descartesian principle. But I mean, it's just funny that it's 400 years ago. The guy had a very kind of I mean, it was fun. He's a Jesuit, and he's really saying something a little bit dangerous, in the sense that he's pretty much arguing that God doesn't need to do anything because everything's already in motion. So he's almost making a determinism argument, besides, where he's basically saying that, there's no way to really escape, that everything's already doing an action and the reaction is inevitable, and that we're basically just stuck in a cause and effect loop, and there's nowhere does the cause and effect loop get deconstructed. Now, the fact is he added some religious crap to say, well, but God can interfere anytime it wants to and save us from cause and effect. But, he was basically making a determinism argument that the physical mechanics are doing that. So it just, like I said, the rolling ball is an example, but I mean, they're all examples that all you're taking energy and you're just saying there's big objects that carry the force. That is, the force has in some previous circumstance, I hit it, okay, with radiation, let's just say. It could be any kind. Let's just make it particles, electrons and protons from a supernova, whatever, and I gave the object motion. And it's carrying the motion, and now I'm going to bang it into something, let's say, that's that's not going to yield the object itself, but the surface will. The surface will fracture and pieces will fly off. So it's a bigger asteroid, and the pieces will fly off. So I'll take that MV that I acquired from some force, and I'll put it back into some little particles again, not as small as electrons and protons, but small. And then I can have those fly into space and hit other little tiny atoms, okay? And now I can start to, put it back into this small stuff. But that's all you're doing. The force goes from being small, it hits big things, pushes them, the big things break down and goes back to being small again. So it's a heat cycle. And so I've pointed out in the gravity argument that that's exactly what gravity does. Gravity takes the mass of an object, okay, and it basically has little tiny discrete particles in space, and they're constantly hitting an object. So no matter, if I did make a universe of just little spots, you could sort of just understand that it's inevitable that if they're all little vectors, that I'm going to get hit by some of them, and it's going to look like they were all heading right for me. So I'm just going to be surrounded by a bunch of vectors that are heading right for me. They might go right through my center, but they might go just through here. They might go through this way. They'll go through all different ways, but they're going to all have a vector that hits me. And those are the ones that I'm going to know about, are the ones that hit me. So it's going to look like the whole universe. I'm going to be just like the opposite of a light bulb. I'm going to have a bunch of stuff in the universe heading right for me and hitting me. And if I was to draw the little rays, it's going to look just like the light bulb or some other thing that's emitting force. But I'm collecting it. And the key is all that force creates incredible pressures inside the Earth because it's slowed down. So you're taking this radiant energy and you're basically just saying, I'm going to hit electrons and protons with it, and they're going to move much slower. So I'm taking a bunch of energy going the speed of light, and I'm going to, just like glass slows down light, I'm going to slow it down. It's going to take time to get through this object. And so what's coming out at the other end is going to be delayed. So the force isn't delayed, right? The universe didn't slow down. It's not going to wait for the counter force to show up. So the counter force just isn't there. It's just going to be a fact. It's going to show up too late. So that's the differential we all fall in. And then when we hit the surface, then we become a constant force, or gravity's constantly pushing on us. So at 1 mile an hour, that's our momentum sitting on the surface of the Earth, 1 mile an hour. If I want to make this scale, it'll read my weight. Okay, and it'll be constant. It's a constant force. The scale stays compressed because it's a constant momentum. And the only argument is how fast would I have to go to have an impulse that's that same weight? And the argument is 1 mile an hour. So that's effectively your momentum into the Earth constantly. So it's, for a person my size, it's like 75 joules of energy going constantly into the Earth. A constant downward arrow, okay? And the Earth provides a push me back. So my body pushes first, the Earth pushes back after I increase the pressure. I have to increase the pressure before it can push me back. But the end result is that pressure always is a vector, and you can't change the vector. So it does go through the Earth eventually. And the simple fact is it takes a long time to get through the Earth, and that differential is what you fall in. So that completes the cycle. So as Descartes was talking, he didn't know all this stuff. I don't know how far he took it. I mean, he clearly, I think, understood that heat was energy, and that motion of like clay or some other stuff that would deform, the deformation was evidence of the energy first causing something to move, and then when it stopped moving, he knew that, well, why did it stop moving? Well, friction. So the stuff was moving, the clay. Why did it stop moving? Friction. So now it's been turned into heat. So the motion was always there. Now the heat just has to dissipate, and that's the hardest one for us to see. So obviously the cycle is created. The whole thermodynamic cycle is all about gravity. You're taking the energy from the universe, and you're basically just creating a cycle, okay, where it's just going to go back out, and it's a constantly refuels itself. It's the only perpetual motion device in the universe, but there it is, gravity. And it's just this process. The fact that pushing matter makes force move slower is why it happens. But it just shows you the energy is always in motion. It's always somewhere. It's either moving the matter, or it's in space ready to hit some other piece of matter and force it to move. So it's either freely flying at the speed of light, or it's pushing matter at some less than the speed of light. And those are the two conditions the force can be in. So I've used the example of Sisyphus, pushing boulders, but that's all it is. There's two. There's just the simple condition. The Sisyphus pushing the boulder has a velocity arrow like that. The Sisyphus flying through space freely, okay, has a velocity arrow like that. And that's the mechanism. It's that simple. And that's really all you're saying is the energy is permanent, it's indestructible, it's always in the universe. The Sisyphuses are a fixed number, the matter bits are a fixed number, and all you're saying is you're just changing in circumstances depending on what kind of circumstance you have. You're either liberating a bunch of Sisyphus and saying you don't have to push electrons and protons anymore, go fly free, or you're binding them in a gravitational body. So when the gravitational body blows apart, when a sun supernovas, it releases a bunch of Sisyphuses that were stuck pushing electrons. A bunch of particles fly out, yes, so some of the Sisyphuses are still pushing. But there's a whole bunch of them who are now not pushing anymore. A bunch of radiation, a bunch of gamma radiation is created, and photons that we end up seeing even. But that's the simple mechanism. I could go a step further and talk about the fact that there's actually two Sisyphuses to match electrons and protons. So there's proton Sisyphuses and electron Sisyphuses, and that they have an inverse relationship when they deal with each other, and yeah, that explains charge, but that's on the website. No need to complicate this energy argument with superfluous, not superfluous, with complications that aren't directly related to the basic function. Now, I guess I could make a more honest, more complete argument would state that because there are two kinds, we know that the photon energy that we see, the stuff at a frequency, only affects electrons. That electrons moving creates electricity. Doesn't have much to do with protons. It's not really part of the equation. And the fact is this gravity argument is probably substantially the proton force, because that exists in the same volume as the electron force, and it's much harder for us to see it because moving protons is harder to do because they're heavier. So we don't see it, but it is the force that's probably generating most of the gravitational pressure. Most of the gravitational reaction is in the form of the proton force. Yeah, I think that's probably good. All right. So I don't hate that as a start. And let's see what else I can add. I mean, I really don't want to get too redundant. Yeah. Let's see. I mean, you just can go over and over and over these things. I don't know whether the jerk has posted his links to the ballistic pendulum, but again, ballistic pendulums are a huge argument. Well, levers are a huge argument in terms of proving there's no such thing as kinetic energy. But obviously, every single ballistic pendulum experiment ever conducted, they can never create a circumstance where this actually does anything but collect the MV, most of it. But it never collects any of the KE above the MV. So I could have, this object could have two, like a bullet, it could have two MV, and it could have I gotta keep that in the frame, don't I? It could have 2,000, joules of KE, huge difference. And what will the pendulum collect? Just the two. So it'll just collect the tiny amount of momentum, and all of the kinetic energy will be lost. So Professor Lewin did this with a bullet, and his calculation was 99.94% of the kinetic energy couldn't be collected. 99.94% couldn't be collected. So with all of our technology, all of our knowledge, all of our capacity to create experiments and do things, we can't do better than that for a bullet. We always have to lose all the kinetic energy above the momentum. And the only thing we can ever collect is just most of the momentum. Not all of it, but most of it. Now, the obvious truth is there is some heat, inside the ballistic pendulum. But the heat inside the ballistic pendulum is just the momentum that it doesn't collect. So it leaves a little bit of momentum in the movement of the clay or the gel inside the pendulum, but it's just the momentum. It completes the momentum number if you add that heat. But you're not going to find 1999.06 joules of heat in the pendulum. And they've never tested it, never put a thermometer in there and tested it. So, I mean, the evidence is overwhelming, okay, that you can't collect it. And it ends up being true for the spaceship. So the ballistic pendulum is just verifying what they already know from space travel, is that, you know, your rocket can produce a thrust, a gigantic amount of thrust, you know, it's a flame. So you could have a kinetic energy of 2,000 joules or 20,000, let's just say, of little particles flying out. But the fact is, if you add up the momentum of the particles, you know, it's only going to be 20. Okay, joules. You can keep it in the same. You can convert newtons into joules, not a problem. And all the spaceship's going to get is the 20 joules of mv. That's all you're going to get, is the momentum. So the third law certainly doesn't in any way cover kinetic energy. It only covers momentum. And momentum's the only thing that is going to be conserved. And there's no explanation of any kind here of where the missing joules are. I mean, obviously this is going to be 20 joules of heat. Okay, that's what we're gonna measure. You know, the intensity of that, not only by just measuring the movement of the particles, but the fact is it's going to have a temperature, because we're directly converting the pressure in the spaceship into heat. So we could just measure the heat, and it's still going to be 20 joules. And so there's 20 joules going that way, and only 20 joules are going to go that way, and that's all you're going to get. You're not going to get anything else. What the hell did this thing just do? Oh, God, it just annoys me. Why did it move my damn frickin'... Shit. Right in the middle of the video, it has to do this crap. Alright, I'll close that and see. No, still didn't do what I needed to do. It's got this stupid taskbar in the middle of my screen for absolutely no good fucking reason. Alright, anyway. Alright, let's see what we got here. When are you going to actually study? Okay, look, this is not a counter argument, so if you can't do better than that, I just block you, whatever. There's just no point in you saying this. My videos have the goddamn fucking lectures actually in them. I've played in my videos all of Professor Lewin's, whatever it is, 101 lectures. All 40, 45 of them. So why don't you go fuck yourself with that kind of crap? It's just so irrelevant. So fuck you. You gotta do a lot better than that, asshole. Alright, why would the kinetic energy of the thrust somehow go into the rocket? Well, I'm just saying, if you're saying it's there, where is it now? So you just tell me, where is it? You're missing, okay, 1980. That's how many, 19,800 joules. Where is it? It's not in the thrust, because we already know the thrust is going to be in momentum. The heat of the fire is going to be measured to be the same as the momentum. You can't make extra heat. Okay, so that's all it's going to be. So where is the 19,800 joules? Where are they? Obviously, they just don't exist. They're a fable. I mean, but the fact that you're saying it's real energy, yet it can't move the spaceship. Well, what can it do? So why don't you show me an example of where it actually does work? It can't do work on a lever. It can't do work on pulleys. It can't do work on a rolling thing. It can't do work... Where? Where does this kinetic energy actually do work? All right. What are you talking about? So I'm just saying, there's just no point in talking to people who think the energy doesn't have to be conserved, that you don't have to explain where the 19,000 joules are. Where are they? Newton's third law says they can't be going that way. We know they're not in the rocket. So where are they? Answer the question, shit for brain. All right, so I'll just remove comments for now, but you're going to get fucking blocked if you're just going to lie and say there's some reason to believe otherwise. The joules are in the thrust. No, they're not. So it's an absolute fact that they're not there. So you can claim they're there, but you're not going to measure them to be there. What are you measuring to say they're there? You're only making it up in a mathematical equation. What we know is the momentum of the thrust. And that's going to equal the heat. They are not missing. So he's laughing like, ha ha ha, they're not missing. Yeah, they are. You haven't provided any evidence of that you somehow have more heat than the momentum could produce. You have no evidence that the heat is any more than the momentum would produce. Just like if I roll something on a surface, it can't create 10 times the heat. It can only create as much heat as that much momentum would create. That's all there is. So you just keep lying, but you have no evidence. You're just going to tell me there's 19,800 joules of heat. Prove it. Yeah, you're never going to prove it. That's the whole point. You're not measuring it. Where did you prove that? Never. You just said that the particles, just like, I mean, this is just so silly, right? You're making the argument, okay? Again, go back to the simplest case. You're making the argument, I compress the spring. We know exactly how much energy it takes to compress the spring. You're claiming, okay, that this thing, okay, that I launch has, these joules of energy, but they don't show up anywhere, okay? So you can claim it, but we know that all they have is an MV. You're saying it's an MV squared. Well, you're just making that up. And the fact is this object it's just going to get the MV part. It's not going to get any of this shit. So I'm just saying you're just making it up. Where do you have the evidence that this is 3 springs? I compressed 3 springs. How did I do 9 times the work? I mean, you're just such pathetic. You can't stay on the subject to save your lives, can you? You just keep lying. Ugh, it's terrible. It was not an argument. It was a question. Well, I didn't see it as a question. It's clear you haven't studied. I'm going to waste my time with this, all right? It's clear I've played every fucking video, every fucking lecture, you fucking piece of shit. So where am I missing? Give me the link to the fucking thing I'm missing, jackass. Show me your great piece of evidence, okay? Or explain this. Explain how the fuck pushing 3 springs was 9 times the work. Explain it, fucker. Quit shit talking. Oh, you're just such a piece of weaselly shit. All right, it's in the thrust, so you can keep lying. It's not there. So show me the experiment where they measured it. They measured the heat, and it came out to be 19,800 joules. Show me one experiment where they did that. Liar. I mean, you're just a fucking liar. All right, you are saying that the kinetic energy of the thrust is not the thrust. I'm obviously saying kinetic energy is a fable. That never happens. There's no such thing as velocity squared, and it never happens. It's never collectible. What don't you understand about the statement? You have to show me an experiment where it is actually collected. Jesus. Can you understand how crazy it is? How crazy it is. How much of a fucking lying sack of shit you have to be. Here's the experiment, motherfucker. You will have no explanation. This took 1 unit of energy. 2 of them, 2 units of energy. 3 of them, 3 units of energy. You're going to claim I have 9 times the energy when I release all 3 of those. How the fuck can I have 9 times the energy when I only put 3 units of energy in? You fucking piece of shit. Newton's third law is not... Yeah, obviously. That's the whole fucking point. The rational physics says you can't do that. And it's clearly saying you will never collect kinetic energy because all you can do is throw momentum one way and get momentum the other way. You can never get its kinetic energy. You can never collect this fake energy, this fucking fairy energy that you pixies believe in. All right, fuck you. You're done. Learn. Fuck you. 10 years I've spent on these subjects. 10 fucking years. I know more about them than you will ever know in the rest of your stinking lousy life because you spend most of your time sticking your fingers up your ass. whatever a mima is. But amazing, they just can't stay on the subject. No experiment collects kinetic energy. It is not a proven to exist thing. The only experiments, I got AI to admit it. The only experiments there are these high school experiments with the plastic carts and the wheels. It even said they use plastic carts, And you fucking morons don't understand. And it says springs. And I've already explained how springs work. Obviously, springs don't give the same energy back to light objects that they give to heavy objects. The heavier the object, the more efficient the spring is. The lighter the object, the less efficient the spring is in giving the energy back. Absolute fact. Have you fuckers looked into it at all? No. Do you care about the truth? No. Why would I pass an exam that's got the wrong questions on it and the wrong answers? So again, you can't do this. You can't do this simple math. You think that if I have a lever, I can put a 1 pound object going 1.4 the velocity, and I can pop out of the other side a 2 pound object going 1 velocity. That I can create free momentum. That's your physics that you're defending, you little putsy piece of shit. You weaselly pile of crap. You can't link to a fucking thing. That's the absolute truth. I've been begging for the link. Show me the link where you collect the kinetic energy. Show me. I mean, the Bruce Yearney experiments with the wooden blocks crashing into each other, just so obvious. A block that has 16 times the energy collides into a block that has 1 unit of energy, and the one with 16 times the energy doesn't win. It means you don't know. Look, you can keep saying absolute useless shit. You can't make a counter argument, then you can just fuck off, okay? There's no point. I mean, I'm not going to listen to you reassert your claim that somehow I'm ignorant, okay? That's useless information. I think you're a smelly piece of rotten human garbage. So what? Make an argument on the subject, fucker. Produce a piece of evidence, fucker. I'll give you time to think about that. James Park. Hey, why don't you visit your house? What the fuck? Hey, why don't I visit your house? Yeah, why don't you go fuck yourself till dead? Alright, yeah, I don't need any house visits. Fucking lunatics. Well, it's not bad faith. There's no debate. He's just insulting me. That's all he has. He doesn't have any fucking argument to make. Kinetic energy is real. They told me so. Look, I've already, the fact is that they're done because they really don't have any experiments except gimmicky, illogical experiments with plastic carts with metal wheels. Okay, so the argument is obviously metal wheels store a bunch of angular rotational momentum. And the rotational momentum won't be revealed in the linear momentum. So they're saying the cart's going twice as fast. Well, it's going more than twice as fast in the sense it's carrying more energy than twice as fast because the wheels are going twice as fast. And they're storing twice as much energy. Well, whatever. I mean, there's nothing else. All there is arguments, and so if you don't want to argue, don't argue. That's your business. I frankly see it as the only viable option, so all you can do is argue and just keep making the point that they're cowards and weasels because they can't draw this, they can't make a video, they can't produce any evidence, they can't do anything relevant to these arguments. They can't make a counter argument to this argument. It's impossible because it's just an absolute fact that I did 3 units of work and I can't possibly have 9 units of work out. 3 units in, 3 units out. There's no other way to do it. I can't make free energy, and it's free energy to say somehow I'm now going 3 times the velocity and now I have 9 times the capacity to do work. I don't. Like I said, you can say people like him. It's people like everyone. It's not like, if this was a rare case of the God botherer who just keeps thumping his Bible and saying the Bible says, and that's all these people are. They're just Bible thumpers. That's all. They don't have any response. They don't have any argument. They just have their faith, their faith, their faith, and that's all they can argue from is their faith. They have no evidence that their silly theory has anything to do with reality, and they just keep arguing, I'm right, you're wrong, I'm right, you're wrong. You can't debate him. He won't respond to any rational arguments. He can't do any math. So what's this crap about? What math do I need to do? What does it have to do with this experiment? What math does this experiment need that'll fix it? That'll make 3 units of work equal 9 units of work? Go ahead, explain it. You won't explain it because you're a weasel. Okay, he doesn't understand, so you're just wasting time again. Just complete waste of time. So if that's all you got, you can just keep making sock accounts and I'll just keep blocking them. Because you're not making an argument. Look, you're wasting time. Make a physics argument or get the fuck out of here. I mean, I gave you the chance. You don't want the chance. Okay, fuck you. Waste of time. You're wrong, you're wrong, you're wrong. Well, that's not an argument. You say so. You don't prove so. The fact that it's okay with you, you think science is not a show me thing. They don't have to show you anything. They just have to tell you a story and you will fall for it. So you think denting clay with round objects is a viable experiment. It will show you the truth. You think rolling a ball across a surface, that friction is always the same. No matter how fast the ball goes, friction is absolutely the same. You believe that crap? Or do you understand that, no, that's right, it can't be the same. It's obvious it can't be the same. I mean, something weighing 30 pounds and something weighing 90 pounds is a huge difference. And it's just silly to say when it weighs 30 pounds, it's got the same capacity to push on the surface as when it weighs 90 pounds. Well, it obviously doesn't have the same capacity. I mean, it's just such poor, pitiful trolling. I mean, they can't make the argument. They can't cite the argument. They can't. I mean, I asked, AI to, well, can you cite an experiment? And all it did was say, well, there are lots of experiments. Yeah, I said cite one. It won't cite any. It just says, hey, there's lots of experiments with springs and stuff. You're not going to get too far there, Mojo guy, posting this fucking bird things. I'm not a big fan of wasted time. I only do it because you people force me to waste time, right? I want to talk about physics. No, I don't want to just waste time. it's everybody to their passion. So, if your passion is, fun, probably this isn't the place for you. My passion is the truth. Defending the real world and the people who have described it in the past. Well, obviously the theory I'm defending here is obviously Descartes. There's no book. You think there's a book that's going to give you the right answers when I'm pointing out that physics in every single case made the wrong choice? I mean, there's no wavicles, there's no spooky action, there's no singularities, there's no superpositions, there's no entanglements, there's no interference. I mean, you go on and on. There's no atom with spinning electrons. None of that shit has anything to do with the reality. So what do you want me to tell you? The book to learn physics is my videos. Just watch the videos. The website has them listed. Okay, thermodynamics, gravity, energy, magnetism, electricity. It's all going to be there. Just watch the videos. I mean, there's a tiny percentage of value. Like I said, I could say go watch Professor Lewin, but like I said, 90% of it's mathematics. And the real point is the concepts are wrong. So it's not very useful. But I mean, understanding the vector math to do the double slit experiment, well, understanding why there's a wavelength of difference and the hypotenuse is one wavelength longer and all that, well, that's useful to understanding, because then you can understand there's only a certain number of fringes that you can possibly create with any size opening, that the size of the opening is basically just telling you how far apart are the two sources, and you're just going to draw your lines from those sources. I mean, that's really simple geometry, but obviously they're doing it completely wrong. They're claiming the vectors are in the middle of the slit, and they're not. They're not in the center of any fucking wave. There's not two waves coming out of the double slit. There's four surfaces creating sources. I'll be infiltrating Wikipedia with your theories. Well, whatever. Obviously, Wikipedia, I have a whole saga of Wikipedia, and they're not going to have any interest whatsoever. Okay, so if you want to just get yourself blocked for life, that's what you'll get for your trouble, because they will not discuss any possibility that the physics they're propagandizing in defense of is at all flawed. Use Newton's third law. And so why would you use F equals ma, right? It's not a real thing. Newton didn't say it, and the a is just a replacement for velocity. It's the change in your velocity. That's what Newton wrote. The change in your momentum. So you're just playing a game, because now later in that formula, F equals ma, you're going to sit there and square the a. Okay, and there's no a squared. So you're just pulling bullshit. It doesn't explain springs. So again, just pull bullshit at me. Where does it explain that the heavy object, the spring, has less energy left in it when it's moving slowly? When the spring expands slowly, it leaves less wobble. When it expands quickly, it wobbles a lot more. Proof that it has more of its energy didn't get out of it. If the spring is still moving, you know that's where the energy is. So I throw a tennis ball at a brick wall. The tennis ball bounces off. Well, the tennis ball is doing this. Do you understand that? Well, that energy is not linear motion, so that's why the tennis ball only comes back with 75% of the momentum I gave it, is because part of the momentum is doing this to the fucking ball. Can you understand these things? God, you people are so dense and stupid. What are you doing this capital letter shit for? What the fuck is your problem? All right, so use Newton's third law. All right, well, fuck you. It doesn't explain shit. Absolute nonsense. Didn't you say physics was on a good track until some split, not 500 years ago? Newton, look, Newton got almost everything right. I mean, he's a pretty damn smart guy. And he didn't overstep his bounds. He didn't speculate. I mean, he could have invented bent space as an excuse. He could have said, well, the space is bent. He could have said something silly, but he didn't, because he didn't have that answer. He didn't think it was a legitimate thing to say. I'm just going to invent a fake mechanism that creates the inverse square law. There. All you have to do is create the inverse square law, right? I could say a light bulb works based on bent space, because bent space is just a replacement for the inverse square law. It's not nothing. It's absolutely a shit answer. So, no, that's not what I did, okay? I said, yes, they kept fucking physics up. I'm just saying what new physics from Newton is good. I'm telling you, entanglement is not good. Superposition isn't good. So you tell me what quantum mechanics is absolute bullshit. The standard model is absolute nonsense. So you tell me what the brilliant insight was after Newton. Now, besides finding electrons and finding protons, I'll give them that much. But clearly Newton was already heading there. I mean, he even anticipated the relativity argument. So the first argument he made in his Principia was the argument against relativity, pointing out that it doesn't explain a spinning bucket. And it doesn't. And it still doesn't. Oh, medieval ideas. Fuck you in the ass till dead. Again, useless rhetoric. Why don't you post a link to something, fucker? Alright, blob is truth, reality. Okay, I'm just going to block you. Hello there, Mojo. Yeah, you're just making a mess, so fuck off. I really don't have an interest. Ugh, people are just so useless. The mind is a terrible thing to waste. Give one to a human and you've just wasted it. Show us where the A is squared. As soon as you put the dt over dt or whatever the fuck you do, and then you end up putting 2 seconds in there, and then you say it's second squared, okay? So it happens in your derivative. You end up saying 9.8 meters per second squared. Obviously, there's no second squared. Okay, it's 1 second. It's 9.8 meters per second over 1 fucking second. Not second squared. Oh, stupid cunts. Oh, no, it's already in your math, okay? The end result, how do you get 9.8 meters per second squared? How do you do it? Where does the square come from? It's not Newton's formula. Newton didn't square the seconds. He didn't say per second, per second. That means it's squared. Second squared. No, it's 1 fucking second, moron. Oh, shit. So no evidence, just nothing. No experimental evidence proving the existence of kinetic energy. No car crash. Nothing. Zero fucking evidence. And they just keep insisting everybody must believe. It takes 25 times the fuel to go 5 times as fast. You must believe because we fucking say so. I mean, these are such religious tyrants. It's worse than the Inquisition, for fuck's sake. These are supposed to be people interested in science. Fuck they are. They have no interest in evidence. They have no interest in logic or reasoning. Again, they will not reason this. They will not explain how it's possible. I do 3 units of work and I have 9 units of energy. In your diagram with the 3 springs using force analysis, there will be 3x the force. Duh. Okay, but the time for which the block will be pushed will be a smaller time. Well, prove it. Prove that the momentums won't be exactly the fucking same obeying the third law. So you're saying that the fucking third law doesn't apply. It absolutely will apply. So you're just a fucking liar. Jesus, you're just such a fucking piece of human garbage. You can't avoid. It's the same fucking momentum on both sides, jackass. Oh, God, you lying sacks of shit. But instead, x squared 3, if you go through the... What the hell? Can't you type? Go through what math? There's no fucking math. You're just saying that somehow 3 units of energy equals 9 units of work. And it doesn't. I just reasoned through, and the paradox. What? I just reasoned through this and the paradox. Can't you type this in better form than this? If it is pushed faster, it won't be in the spring for a long time. We're not talking. We're just saying there's no way you can make this garbage excuse that somehow these 3 objects will not leave at the same velocity. They will. This one will leave at the same velocity. This will leave at the same velocity. This will leave at the same velocity. So you're just making shit up. Yes. Now hold on a minute, please. Alright, I should be back. Interruptions and such. 3x the force, but less time. So this is just nonsense. There's no less time. It's the momentum is clear. There's no doubts about the fucking goddamn momentum. You have this. These are 10-pound objects. This is a 100-pound object. These 10-pound objects are going to have a velocity, okay? And each one is going to increase the velocity of this object exactly the same, exactly as Newton says. So fuck you. You're just full of shit. You're just making up a fake argument, okay, that has nothing to do with the reality. Your own physicist will concede there's no way around it. I'm sending 3 objects with a fixed momentum. I'm going to get a fixed momentum in the opposite direction. And it's just an absolute fact that 3 units of work cannot equal 9 units of energy. No, you people are just such pitiful, lying sacks of shit. Contriving nonsense. All of a sudden, the 3 springs don't work. They completely failed to function. And the object still moves, even though the springs completely failed to work. Somehow the object still moves with 3 times the velocity. Well, what's your argument? Well, there's no argument, but you already know how spaceships work, and the momentum always is conserved. Always is conserved. I'm not going to play this game with you. Is the momentum always conserved or not, fucker? I don't have to agree with you. Do you agree that the momentum has to be conserved? The same momentum going this way is the same momentum going that way. Is that true or not, fucker? Oh, god damn. Experiencing the force for 5 seconds versus 1 second difference in final velocity. Yes or no? I'm definitely engaging. But no, you're not engaging with it at all. What the fuck does time have to do with this? It has absolutely nothing to do with it. We know that the 1 spring produces a 1 velocity. The 2 springs will produce 2 velocity. 3 springs will produce 3 velocity. Period. End of the subject. The momentum will be the same on this side as on that side. And the simple fact is I will have 3 times the velocity and I will not have done 3 times the work. You fucking lying sack of shit. Alright, you're fucking done. You're just a waste of time. Fuck off. No evidence. Nothing. Somehow there's a magical flaw in this experiment, but no, they won't tell me what the magical flaw is. Somehow the speed of the spring they just don't work anymore. Well, but they'll concede that the momentum has to be conserved, so it doesn't really matter if the springs fail because they have to fail on both sides of the equation. I'm still going to be going 3 times as fast, and you can't change that, fucker. people. All right, 2-minute warning. There's no point. I mean, it's just there's no point. Nobody can show up here and just make the simple concession that, yeah, physics really needs to clean this up. This theory that it takes 25 times the fuel to go 5 times as fast is obviously idiotic. It obviously doesn't happen. So why are people defending absolute nonsense? The law of the lever does work. It is reliable, and you can't make free fucking energy. All right. This shouldn't have to happen. This should not be an argument. You all should be saying, I want better evidence. That's what you should be saying. I want to see it. Show me it taking 25 times the fuel to move something 5 times as fast, especially spinning something 5 times as fast. Show me. Show me the electric turbine spinning twice as fast, making 4 times the energy. Or show me the turbine moving 3 times as fast, producing 9 times the electricity. Or 4 times as fast, producing 16 times the energy. Show me. You should be saying, show me that. It's so disappointing. There's so few fair, reasonable people on this fucking scummy planet. Just defending your fucking Bibles. You're all a bunch of jihading fucking religious kooks. You believe not because you see anything, not because you've been shown anything, because they told you to. Have you ever seen a quark? No. Do you know anything about how they detect quarks? Well, it's hard to know anything because, frankly, they don't even tell you that. They don't even tell you the magical experiment that proved the existence of quarks. And all it is an electron deflection experiment, right? So they take what they presume to be an atomic nucleus of some kind, who knows, and they shoot electrons at it. And some of the electrons deflect this way. Oh, that's a strange. Okay, and some deflect this way. Oh, that's a down. And that's it. That's quarks. Because they think they're hitting a single proton. And they think because something deflects off the proton one way or the other way, that somehow that means there were different things that caused the reflection. When you could obviously say, well, if the proton had a shape, even like a circle, obviously things that hit this side of the circle go that way, and obviously things that hit that side of the circle go that way. I mean, duh. But that's how bad it is. So they tell a whole story based on this fucking bullshit experiment. They invent a whole theory about all kinds of up, down, half spin, quarter spin, bullshit crap. And you people just accept it because they say so. Ugh. So this is Ziggy's wasting time, right? 180-year-old cousin Ziggy. He used to show streams back in the Stickum days. Word has it, I don't really give a shit what the hell you're fucking talking about. Go to hell. Oh, fuck. Die horribly first, please, and then go to hell. Come back on Earth, born in Indonesia or something. God, human garbage everywhere. So as always, there's an email address right there in the description. ts@donotgo.com. If you have some evidence, you know, even if I blocked you, you can still send emails. So go ahead, send me some brilliant crap that proves the existence of kinetic energy. Show me the evidence that convinces you. You hate Indonesia. I'd hate to be born there, yeah. Indonesia is full of lunatics. You know, you want to go, you want to go find a lunatic? Go to Indonesia. You'll find a lunatic. They're all over the place. I mean, I could have said Bangladesh. I could have said lots of places. There's lots of shitholes on planet Earth that I'd be scared to death, you know, to have to wake up in. I mean, there's people literally having babies on garbage piles. Literally. Whatever, but you're way off the subjects, but whatever, fuck you. Just, how about the double the B fields? So what does that have to do with anything? Quadruple the force. I mean, what does the B field have to do with anything? Okay, polarized objects are completely, you know, they're completely different in terms of their, you know, the fact is they lose, they become weaker in less time because of the simple fact. You could understand a north side and a south side, an electron and a proton, for example. What happens over distance, right? So you could argue that the force this way, okay, it always stays the same this way, but obviously this way, okay, at a distance, you're just going to see purple, okay, because the reds are going to mix with the blues, and you're going to lose your force. So obviously it's not an inverse square law anymore, because this polarity means that you're going to start mixing the forces, and so whatever you were getting in your test particle is going to turn to nothing. But it's really way off the subject, and it's on the website for, you know, in fact, okay, there's videos explaining how electricity works in wires, and why, you know, there's a, every time an electron moves, it creates, it reflects the force coming at it, so it creates a change in the frequency, and the phase also. And so all you're saying is when electricity is going through atoms, it's, you know, it's pushing on electrons this way, and when it pushes on an electron this way, the atom pushes on the electrons that way. So it's kind of obvious why it's perpendicular to the force. But again, it's really not the subject. The subject's kind of obvious, and you've got to change the subject. Ah, this doesn't erase. I forgot. I told you I'm making a video. You didn't knock. All kinds of stuff. People are so annoying. Gotta live with annoying people. Gotta listen to annoying people. However, we're off the subject of Indonesia. Thank you. Ugh, shit. All right, 2-minute warning. 1.5-minute warning, maybe. Yeah. See if anybody has anything reasonable to say. What we'll never hear is them just conceding. Okay, I get it. You have some pretty good arguments. They really should be addressed by physics. It doesn't seem unreasonable that you certainly, I mean, based on all of the evidence against kinetic energy, it does seem like it's a perfectly reasonable argument to make that, well, if you can't collect it, it's not real. And that the fact is, if you made it disappear tomorrow, your physics isn't going to get worse, it's going to get better. If you just quit squaring that velocity, you're not going to get wrong answers, you're going to get righter answers. Because momentum is conserved, and momentum controls everything. Momentum moves from object to object. Heat is momentum. Pressure is momentum. Weight is momentum. I mean, I proved it already. You can crash into a scale and create your weight with a velocity, an mv, and it will create your weight. So disappointing. Oh, people. All right, 30 seconds or something. Down to 10 viewers anyway, so I don't think much is going to happen that will be of much use. So we shall see you next time and such. Simulations coming soon and such and so forth and whatnot. So till the next time, blah 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 blah. Hate your guts and get what you deserve. Pretty much. I wish. Yeah, it seems like a pretty simple thing to request from the universe. Let them get what they deserve. Oh, it'd just be so splendid.